name is Amir Rubin. I am president of Paracosm. We are as of recently this year, division of Occipital, who is the world-leading spatial computing company. We specialize in developing 3D spatial sensors that sense the world in 3D and software that lets these sensors understand, map the environment. And so the class of software that everything is built on is called SLAM software. And what's really exciting about it is that it lets us map environments and track the position of our users without the need for GPS. So when this capability is coupled with a LiDAR system, such as the Velodyne VLP16, it opens up a new class of applications that let us create 3D maps of environments where there's no GPS capability. And so when you have like a self-driving car, there's usually, you can have a GPS antenna on your car. When you are mapping, pure outdoor environments, you can have a GPS signal. But there is an upcoming wave of applications for indoor environments that need to be able to map and track position indoors. And this is everything from having a warehouse that we want to map so that we can manage the warehouse, and even have an autonomous robot drive through the warehouse. We want to be able to map data centers to be able to manage a data center, construction sites, power plants, and even for certain environments where there's a lot of forestry environments for forestry management where GPS signals don't work well. And so what we've developed at Paracosm and what we've spent the past 5 years developing is a suite of software that takes data from a camera, LiDAR, and an inertial measurement sensor and allows us to very accurately track a user's position and map their environment. And so what we would like to show you today is the result of this years of development that we're calling the PX80. And so the PX80 is a completely self-contained handheld device. The core sensor is the Velodyne VLP16. It's a very powerful device. It can sense up to 100 meter range with a plus or minus 3 centimeter accuracy per point. It works indoors and outdoors. And what's really cool is we fuse this with a very wide angle 250 degree color camera, which lets us add color to the Velodyne's puck data. We have fully self-contained battery processing and inertial sensors inside of here that let us, as you're walking in real time, do a quick pass of your data so that you can, in real time, start to map your environment. And Nick's gonna hold up here and just show you. All our users do is grab the PX80 device, walk through the environment, and as they're scanning, they see a real-time preview of everything they're scanning. And it's all happening on the device. For large, complex environments, once a user is finished with their scanning, they just hit stop, post-process the results directly on device, and in a little bit of extra time, you have to wait a few minutes, the device will process, reprocess, and make a very nice globally accurate model of your environment. So what we'll do right now is we did a little bit of a pre-canned demo. Earlier today, we spent just a few seconds walking around the show floor, and what you'll see is, we'll pop over to here. This is, I think this was less than 1 minute of walking around the show floor, and you can see we have full color Velodyne 16 scan, full color point cloud of, this is our occipital booth here. And you can see all the halos from the, floating above the hall. You can see, everyone's billboards and signs. And so, you can see in full color all of the signage, people walking down the floor, everyone's booths. And this is a metrically accurate 3D capture done in under 1 minute of walking around. And the implications for this, again, are entirely new paradigms of being able to map an environment incredibly quickly for robots to map an environment incredibly quickly, to manage the progress of a construction site, map complex environments that were not previously mappable before, such as like power plants and nuclear facilities we have customers interested in. And so what we're going to show next is some fun customer examples. We package the product with an iPad so that you can control everything, view your real-time preview, manage all the data you captured. And once your data is exported, we have a viewer suite that we call Job Site that lets you view the imagery you captured overlaid with your point cloud data. So you also get an instant Google Street View style view of what you captured. So this is really exciting because for the first time, you can virtually capture to a very high degree of accuracy, to several centimeters of accuracy, these environments that were not even being able to be mapped before. And then we compare this to classic tripod scanners that are, while they're sub-millimeter accuracy, tripod scanners need to be placed in specific positions and post-registered after the fact. And what would typically take a 3 or 4 hour scan time with the tripod is the time it takes to walk through a site for us, 5 or 10 minutes. And then in addition, tripod scanners need to be registered after the fact. This can take several days of work or several hours. And with us, it's all automated through our SLAM processing software. And so, again, it's as easy as walking indoors, outdoors. Everything is entirely self-contained. What you end up with is these amazing scans where for this scan, we walked in a circle around this building. We did walk on the roof to capture the rooftop data. We've captured the complete outdoors. Then with the same device, we walked through the indoor of the building, and with the Velodyne VLP16 and our camera and Paracosm software, we're mapping these incredibly complex spaces that were unmappable before. So the engineers, the civil contractors, mechanical contractors, facility managers don't have this stuff documented. We have it now. They have it in 3 centimeter accuracy, full color, captured in the time it takes to walk through. But even you see, we're walking through these tiny little cramped hallways. A tripod wouldn't even fit there. No other technology is capable of doing this. And we can now allow anyone in the world to virtually visit and be present in these sites. Pretty cool. All the ductwork captured. So people are doing this also during construction to ensure that construction is happening according to the architectural and building models. They're doing it to be able to perform remote safety and site inspections to verify that what is happening on site or as built matches the floor plans. And in certain situations, for example, this incredibly complex environment with a spaghetti of pipes and buildings, plans don't even exist. So now we're able to let people capture and create their own plans. This is a scan done outdoors. This is actually from the first video of the guy scanning. And you can see here, this is just from walking down the street, and we completely capture the entire infrastructure of the road in full 3D. This is not done with GPS. This is just done, and it was not done from a drone. This is done from a handheld scan, capturing not just all the buildings and the parked cars, but the overhead power utility poles, the street lights, the traffic lights, all the road markings. And we're actually working with customers to use this data for civil infrastructure inspection. So we have our system. What's really exciting about it is we are able to work with partners to interface with a wide variety of sensors. For example, with this customer, we interface to their ground penetrating radar system. And we were able to overlay the ground penetrating radar to this street view and precisely identify the location of potholes, surface cracks, underground water mains and pipes. And for the first time, we have an entirely new method of capturing a new class of data set. This customer was building a one of the largest liquid natural gas processing facility in the country. And what you can see here is they're building these enormous tracks of pipeline that a person can't even walk, and GPS is not feasible when there is so much metal infrastructure going around. So the GPS, forget it. Tripod scanning is not even feasible. And so we hopped in the truck with our customer, held the PX80 out the window, drove through the site, and we capture all of the materials, all of their piles and staging area, full color, full detail. We capture all of the very complex piping and construction infrastructure they're building, all in the time it took to drive a truck through there. We hop out of the truck, walk through their stockpiles, and everything's fully captured. And then they decided to stress test our system, and they took our PX80 out to into the actual structure that they're building. And so we started walking around the actual pipes, and we're able to capture in full detail the machinery, all the heavy equipment, and even these really complex metal structures, which are almost impossible to track without this technology. So Paracosm's PX80 is able to capture in, I think this was a 30-minute walkthrough with some post-processing time, to see every metal strut, every pipe, every girder, the entire trestle infrastructure here was able to be extracted and compared to the engineering drawings, and to ensure that everything is being built correctly to spec, to ensure that construction progress is happening on schedule, and just as a general quality control step for this mission critical project where these enormous pipe trestles are being built, and the pipe needs to make sure to meet up in the middle. So you need a very accurate, quick way to verify construction real time as it's being built to prevent really costly disasters. It's much easier to make a correction before something is built than after. So for the first time, we're enabling people to capture the environment as they need the information. So it's instantly actionable before a slight mistake in the placement of a pipe becomes a real disaster. This is a cool environment. We have a pretty large warehouse type environment captured in just a few minutes. And a lot of people are actually interested in this new class of application that we kind of call like a reality version control. So a lot of environments, perhaps it's a warehouse environment, perhaps it's a retail environment, are constantly changing, and there's not really a good way to always know what's happening with your environment. So again, this real-time instant mapping system, for the first time, lets us walk through and completely virtually capture a space, full 3D, full measurements, full photos, and because it's so fast to capture and you can capture frequently, people are able to now scan once a week, once a day, in the morning and then in the afternoon, and then analyze the scans to see effectively the deltas between the scans. So in this environment here, we scanned, just as a proof of concept, we scanned once in the morning and then again a few hours later, and then you can see there's a we highlight in red and green the delta, the differences between the two scans, what's changed. And so you see, we'll pop through a few different views. The big idea is spaces that change often. I want to know between this day, between Monday and then between Friday, what moved, what changed. I want to know what went missing, or what changed location, or what's new on Friday that wasn't there Monday, vice versa. And so there's this whole new class of application that we're enabling our customers to develop, which is this version control reality that gives us a time slice and an elapsed view of spaces over time. So again, this lets us monitor construction progress for complex manufacturing facilities. It lets you track how you're moving your equipment around, and then for forestry, you can see how their trees are being cut down and things like that. For data centers, it lets you see how your racks are moving day to day. And so instant 3D mapping, never before possible, real-time data capture enables new class of reality differencing. So you can see for the next scan, the blue objects are present, and they were not present before. We have some other fun viewpoints that we'll jump around to. You can see, this device, as they build these devices, they move them up and down, but the green objects are not present in the second scan, and the blue objects are, and they fill in. We actually get a lot of requests from people who want to scan enormous venues, whether it's for event planning or space planning, and surprisingly, a lot of sports stadiums really want this. So, scanning sports stadiums, as an example, would usually take you 1 or 2 days of tripod scanning with traditional scanning methods, and then several days of post-processing to get a result of an enormous stadium. With the Paracosm system, we spent 15 minutes walking through the stands here, and we captured the entire University of Florida football stadium. And what's cool is you can kind of see, this is captured from the viewpoint of our scanner. You can see all the elements, all the sensors of our system fusing together here. We have imagery captured from the camera on the top of the PX80. We have the 3D LiDAR points that you see overlaid. And our Paracosm and occipital SLAM software is calculating the walking position as we walk through the stands. You can see this is the floor. These little guide points show my walking path. And what we've effectively done here is we've recreated the space virtually, and we're even able to have this Google Street View style walkthrough of both the 3D point cloud data generated from the LiDAR and the actual spherical camera data that you can see here. So again, it's a complete virtual presence that now allows anyone in the world to virtually visit our stadium. And there's just no other feasible way of capturing these enormous areas that doesn't require an insane amount of tripod setup and point cloud registry. One of the exciting partnerships that, since we've been acquired by Occipital, which was announced earlier this year, is is an integration into the Occipital scan to CAD workflow. So it's a quick video, but what you see here is this enormous and pretty exciting new building being built in our home office of the town of Gainesville, Florida, where we did a quick walk around of this building, captured a point cloud, and processed it through our Canvas scan to CAD service. So we're able to take this full point cloud and even convert it into a CAD model that can then be used by designers and modelers to do whatever other planning they want. And we have customers using this now for large venues to be able to plan events. They can take the CAD model, import it directly into SketchUp, plan how their tables are going to be, their PA systems are going to be for events. They're using these to import directly into Revit for use with client presentations. A lot of building owners just want this documentation to have an accurate CAD model of their buildings. And so it's really exciting what can happen when 3D is made very accessible. And we were working on building out these complete workflows for customers doing anything ranging from needing a CAD model to needing a time-lapse view of space over time to virtual presence to Google Street View. This is all captured with the Paracosm PX80. And so I've been just about taken up the first half of my time. Does anyone have any questions? Currently we're using the VLP16s, and our goal is to make 3D capture as disruptive as possible. So we're committed to constantly striving to drive the size, weight, costs, and power consumption of our devices down, and even the price down, because we see this as more than just 3D mapping, 3D scanning. We see it as a way to truly democratize 3D mapping the entire world, indoors, outdoors, remote regions. And so we're committed to moving to solid state once that's made generally available. For the differencing algorithm, the user scans the building twice, and then the question is, how do we find the differencing? And that's currently a system that we're developing ourselves. It's currently only released to certain pilot customers. So it's not generally available yet, but if that's one of your use cases, talk to us after. But that's something that we provide to our pilot customers, yes. Every data set that I showed off is captured from a single LiDAR. And so what's really exciting is the LiDAR has a 100-meter range, but because it's mobile, from the single PX80, we walk or drive through an environment, and like this environment is still captured from a single LiDAR because we move through the environment and we're constantly building the point cloud as we move through. So one PX80, one LiDAR, full data capture. For autonomous vehicles, there's, do they need the full map? I guess it depends. Certain elements of the map it's a very accurate map, and then the elements that we really care about, the buildings, the roads, traffic lights, the trees, we want to know them, we want to reuse that elements in whatever we want our map for. And especially for indoor autonomous use cases where we eventually want to have a robot driving through a factory or a warehouse or something, we want to be able to preserve the maps at least to be able to use for planning paths and positions and things like that.